Hello everybody, this is our mini video recording for the lesson 1.09, which is the second part of reasoning. So in today's mini video, we'll talk about conditional statements, the converse, inverse, and contrapositive statements, and also biconditional statements. So let's first take a look at conditional statements. So these are declarative statements, okay, which either have a true or false truth value, but never both, okay? So they can either be true or they can be false. These conditional statements are written in an if-then format, and it has two parts, a hypothesis and a conclusion. So the hypothesis is the if part. Okay, it's at the beginning, the if part. And the conclusion is what happens at the end. That is the then part. So if I get paid, then I will take you to the movies. That's an example of a conditional statement. You are setting a condition, or I am setting a condition in order for something else to happen. To represent the if-then statements, a lot of times they'll use P and Q, which seems kind of weird, but P is the hypothesis and Q is the conclusion. So it'll be written like this: if P, then Q. And you can also see where it has the arrows. It'll say P, arrow Q. So P implies Q is then going to happen. So if you can write your statement, or if you can write your sentence in an if-then format, then that makes it a conditional statement, okay? All definitions, postulates, and theorems can be written in an if P, then Q. So if two lines are parallel, then they do not intersect, okay? If two angles are complementary, then they add up to 90 degrees, okay? Those are just some basic examples. So our conditional statement says, if P, then Q. So if you like rock and roll, then you like loud music, okay? So there's three other types of statements that can come from a normal conditional statement. The first one is the converse, okay? So notice we have P implies Q. So if P, then Q. And then converse comes in and says Q implies P. So if Q, then P. So all we did was switch. All we did was switch. So converse means to switch P and Q. Okay? So before, our conditional statement was, if you like rock and roll, then you like loud music. So we're going to switch them up, and it says, if you like loud music, then you like rock and roll. Okay? We just switched our hypothesis and the conclusion. The next one is the inverse. Okay, so what these squiggly lines mean is not, or you negate them. Okay, you negate them. I'm going to write that down. So we're going to negate P and Q. So to negate something, it would be like if my original statement said, I like broccoli. If I negated that, then I would say, I do not like broccoli. Or the opposite, okay, it just means the opposite. But if I were to say, I don't like to run, or I do not like to run, if we negated it, then we would say, I do like to run. So negating is just the opposite, and you have to do it with P and Q. So we go back to our original statement, which was, if you like rock and roll, then you like loud music. And when we negate that, we say, if you do not like rock and roll, then you do not like loud music. Okay? The next one is contrapositive. So as you can see, it has the little tildes, which means negate. Okay? So we're negating both of them, but we're also switching them. So contrapositive means we switch and negate P and Q, or the hypothesis and the conclusion. Okay? So it says, if you do not like loud music, then you do not like rock and roll. And what you can do, what I like to do, is I like to just go back to my converse statement where I've already switched them, and then just negate that. Okay. So when it said, if you like loud music, negating it goes, if you do not like loud music. Okay. Let's do some more examples here. So remember, converse means to switch. Converse means to switch. So it went P goes to Q, turns into Q to P. Okay? Q to P. So if our original statement, if a figure is a rectangle, then it has 4 right angles. So let's go ahead and label what our hypothesis is. The hypothesis is the if part, okay? We're going to call that our P. The conclusion, which is the back part, that is our Q. And remember, for converse, we just switch them. So it would say, if a figure has 4 right angles, then it is a rectangle. And notice what I did, the word figure was up with the first part. And so it's okay if it stays at the beginning with the if part. The main part of this is a rectangle. That's what gets moved, okay? So if you have to kind of change the, to make it grammatically correct or to make it, for it to make sense there in your wording, like we need to know that it was a figure that we're talking about. You can keep that at the beginning, okay? Okay, remember the next one is inverse. So we start with P, if P then Q. The inverse means we negate it. So it says not P, not Q. So if a figure is a rectangle, then it has 4 right angles. So here is our P, here is our Q. So we're going to keep it in the same order, but just negate. So it says, if a figure is not a rectangle, then it does not have 4 right angles. Okay, the last one is contrapositive, and that's when we switch and negate, okay? Switch and negate, so that, remember our original conditional said P, if P then Q. So we're going to switch them, making the PQ, and then we have to negate both of them. So our original conditional statement was, if a figure is a rectangle, then it has 4 right angles. So we're going to switch them and negate them. So if a figure does not have 4 right angles, then it is not a rectangle. Okay, so this is just a wrap-up slide for converse, inverse, contrapositive, so that way you can have all the notes in one screen. Okay, so if you want to go ahead and grab a screenshot of that, you can. It has everything that we just went over. So let's do one more example here. If a polygon has 3 sides, so remember, this is our P to Q. So the converse is just going to go Q to P. So if a polygon has 3 sides, this is our hypothesis, which is P. It is a triangle. That is our Q. So we're going to switch them. So we're going to say, if a polygon has or is a triangle, then it has 3 sides. Perfect. Okay, so to do the inverse, remember, we always go back to our original conditional statement, okay? We've written that converse statement, and we're going to go, so to do our inverse, we're going to go back to the conditional. So the conditional statement says, if a polygon has 3 sides, then it is a triangle. So we're going to, remember, inverse, we leave it with P, Q, but we're going to negate both of them. So we're going to say, if a figure, or if a polygon does not have 3 sides, then it does, or then it is not a triangle. Okay, and the last one is contrapositive. Okay, so we switch them. So it'd be Q to P, and we negate both of them. So if it says, if a polygon has 3 sides, then it is a triangle. We're going to switch it so we can look back at our converse statement. Okay, so the contrapositive here. So we're going to switch it and negate it. So we say, we can go back and we can look at our converse statement, which was, if a polygon is a triangle, then it has 3 sides. So we can say, if a polygon is not a triangle, then it does not have 3 sides. Okay. So let's take a look here at truth. These are called truth tables, okay? And basically it's a way to organize the truth value for the additional statement, or for each of the different statements, okay? So if P then Q, okay? If P then Q. And our statement says, if I get paid, then I will take you to the movies. So if I get paid, then I will take you to the movies. So what this truth table does is say, like, let's look at this first one. The hypothesis is true, which means I did get paid. Okay, so I got paid. The conclusion happened as well. I took you to the movies. So did the conditional statement of, if I get paid, then I take you to the movies, did it hold true? Like, did I tell you the truth? Yes, I stuck to my word. I got paid and I took you to the movies. Okay, I didn't lie to you. The next one, the hypothesis is true. So I did get paid, but the conclusion's false. So I did not take you to the movies. I lied to you, right? I lied to you. So that would be false. It didn't have, the conditional statement did not hold true. Okay, this last one says, if I get paid, then I will take you to the movies. So I did not get paid. I didn't get paid, but I still took you to the movies. This one's weird, okay? Most of us want to say, oh no, that one's false. You took me to the movies, but you didn't get paid. Okay, I didn't say, this is weird, but I didn't say that the only way I'd take you to the movies is if I get paid, okay? I might have found money in my couch cushion. So this one is actually true. I didn't lie to you. I didn't break a promise, okay? I did not, think about breaking a promise. I didn't break any promises there. The last one says I did not get paid and I did not take you to the movies. So I didn't break any promises. It was still true, okay? So this is a way to organize the different scenarios with the conditional statements, okay? For the truth tables, just so you know, the conditional statement and the contrapositive statement, you can see here that they have the same truth values, okay? And then the inverse statement and the converse statements have the same truth value. So if the conditional statement is true, then the contrapositive statement will be true. If the inverse statement's true, then the converse statement will be true. Okay? The last type of statements we're going to talk about are biconditional statements. Okay? So remember that a conditional statement says if hypothesis, then conclusion. If conclusion, then hypothesis is the converse, right? Remember, converse just means to switch them. For the biconditional, okay, if both the conditional and its converse are both true, then it can be written as a biconditional statement, which says hypothesis, if and only if conclusion. Okay? Let's look at an example. So for this one here, we have the conditional statement, which is if, or right here, this conditional statement, if the battery-powered calculator runs, then the batteries are good. Okay. The converse says if the batteries are good, then the battery-powered calculator runs. Okay, great. So both of these are true. Both of these are true. If it runs, then that means the batteries are good. If the batteries are good, then the calculator will run. Okay, so the biconditional statement would say the battery-powered calculator runs if and only if the batteries are good. Okay, so if both of these are true, then you can have a biconditional statement which says if and only if. Let's look at these examples here. Determine if the biconditional statements are true or false. A number is a multiple of 5 if and only if the number is odd. Okay, so they're saying that any number is a multiple of 5 if the number is odd. A number is a multiple of 5 if and only if the number is odd. Well, what about 20? 20 is a multiple of 5, and it's not odd. So this would be false. And remember, to find the true false value, in order for the statement to be false, you just need to come up with one example. That's it. Okay? The next one says, two angles have the same measure if and only if they are congruent. Well, yeah, it means the same thing, right? If they have the same measure, 40 degrees and 40 degrees, then they're congruent. If two angles are congruent, then we know their measure is the same. This one is true. The last example says 3 points are collinear if and only if they lie on the same line. Yeah, the 3 points, if they're collinear, then they lay on the same line. If they lay on the same line, then they're collinear. This would be true. Okay, guys, remember, make sure you're going through the content because there's lots of practice problems in there and more definitions. The lesson is full of vocabulary. I say this over and over again, so be sure to review the vocabulary words and use notes when you are completing the assignments.